Hello, my name is Mama Azim bin Maisa. I am very thankful to be given the chance to speak here. Today, I will be talking about what is welding. So, welding is a fabrication process that joins materials, usually metals or thermoplastics, by using high heat to melt the parts together and allowing them to cool. Welding is distinct from lower temperature metal joining techniques such as brazing and soldering, which do not melt the base metal. In addition to melting the base metal, a filler material is typically added to the joint to form a pool of molten material. Based on weld configuration can be stronger than the base material. Pressure may also be used conjunction with heat or by itself to produce a weld. Welding also requires a form of shield to protect the filler metals or melted metals from being contaminated or oxidized. Many different energy sources can be used for welding, including a gas flame, an electric arc, a laser, an electron beam, friction, and ultrasound. While often an industrial process, welding may be performed in many different environments, including in open air, underwater, and in outer space. Welding is a hazardous undertaking and precautions are required to avoid burns, electric shock, vision damage, inhalation of poisonous gases and fumes, and exposure to intense ultraviolet radiation. Until the end of the 19th century, the only welding process was forge welding, which blacksmiths had used for millennia to join iron and steel by heating and hammering. Arc welding and oxy-fuel welding were among the first processes to develop late in the century, and electric resistance welding followed soon after. Welding technology advanced quickly during the early 20th century as world wars drove the demand for reliable and inexpensive joining methods. Following the wars, several modern welding techniques were developed, including manual methods like shielded metal arc welding, now one of the most popular welding methods, as well as semi-automatic and automatic processes such as gas metal arc welding, submerged arc welding, flux core arc welding, and electroslag welding. Developments continue with the invention of laser beam welding, electron beam welding, magnetic pulse welding, and friction stir welding in the latter half of the century. Today, as the science continues to advance, robot welding is commonplace in industrial settings, and researchers continue to develop new welding methods and gain greater understanding of weld quality. Automotive applications of welding. A wide variety of automobile body components are joined together using welding techniques. The necessity for development of new welding techniques for automotive applications is ever growing to meet the new material combinations for auto body parts. The requirement for innovative welding processes is felt strongly in the recent days, with automotive manufacturers focusing on lighter yet strong and fuel efficient vehicles employing lightweight alternative materials. And autobody technicians use a variety of automotive welding techniques to complete structural repairs on various vehicles and equipment. The most commonly used welding methods for automotive applications are resistance spot welding, resistance seam welding, metal inert gas welding, tungsten inert gas welding, as also laser beam welding, friction welding, and plasma arc welding. Examples of automotive welding. There are many ways to use welding on cars to repair collision damage or damage due to age of the car. Here are some welding applications for vehicles. The first one is vehicle frame or fender welding. Vehicle frames and fenders become bent or damaged in collisions. A technician may need to cut out the warped piece of metal and replace it with a new piece. He or she can use automotive welding to adhere the new piece of metal and repair the car's frame or fender safely. The second is welding exhaust on a car. Exhaust systems can rust and develop holes due to age, moisture, and constant use. Some autobody technicians can cut the exhaust pipe, clamp the pieces, apply spot welding, and complete the weld. The third is wheel welding. This type of welding on cars is helpful to repair wheels damaged by potholes, which often crack metal with wheel frames. Some autobody welders can repair the wheel frame using a TIG welder.
Assalamualaikum and hi, my name is Muhammad ZIKRI bin HASNI from class DKM 1A. My matrix number is 09DKM20F2004. The topic that I would like to share to all of you is the type of welding used in car. Carbon steel welding is mostly done through MIG welding. GMAW is defined as arc welding using a continuously fed consumable electrode and a shielding gas. GMAW is also known as MIG, which is metal inert gas. It produces high quality welds. It is also yields high productivity. MIG welding was originally invented in the 19th century when Humphrey Davy discovered the electric arc. Originally, carbon electrodes were used but later substituted by metal ones. The first innovation came in 1920 when a bare electrode wire and direct current were used with an arc voltage to regulate the feed rate. Today, MIG welding is seen as one of the most popular welding processes, especially in the sheet metal industry. Consequently, it is an important factor for the automotive industry as well. A lot of people are still fixing automobile parts on their own in their garage with MIG welders. The greatest advantage of MIG welding in the automobile industry is that it is capable of producing clean welds. Not only that, but it's great for precise work. There is minimal splatter and you can work with dissimilar metals easily. MIG or metal inert gas welding is known as gas metal arc welding or GMAW. Also use a gas shield and filler material. However, in this case, the filler is a wire fed directly through the welder. That makes this a one-handed process, so you can keep the other hand free for manipulating your materials and other tools. MIG welding is quicker than most other welding methods. It's not as precise as TIG, but it's still relatively clean. It's also much easier to learn and can be a great place to start learning. MIG is going to be a go-to welding type for most auto body repairs. It works best because it is good for many types of metal and is suitable for quick repairs. It can handle a wider range of thickness than TIG or stick. MIG can handle the materials used in auto bodies without sacrificing strange or clean appearance. The newer MIG welding machines also have tons of options that make it easy to avoid distortions. It is also one of the easier process to learn. For seasoned veterans and new welders alike, it's the best choice for auto repairs. MIG weldings are by far the go-to welders for beginners because of the
Hi guys, I am SAILESHWAR PILLAI, son of V.RAVINDRAN. My matrix number is 09 DKM 20F 2016. So today I'll be talking about the disadvantages and advantages of MIG welding. MIG welding is arguably the easiest welding process for a novice welder and one of the most versatile for a skilled professional, whether you're working in automotive chassis construction or container fabrication. But what are the headlines, advantages and disadvantages of MIG welding? The first advantage of MIG welding, it has a higher productivity rate. 8 out of 10 welders prefer higher productivity welding due to time saved by not having to constantly change rod or chip away slag. It also doesn't require brush the weld repetitively. They are able to work faster and cleaner. Secondly, MIG welding is the simplest to learn. Welders can learn or educate others how to MIG weld in few hours, and some instructors claim they can provide a basic training in 20 minutes with majority of time being spent on cleaning the weld. In comparison, TIG welding takes a long time to learn, and most welders working on home project wouldn't want to invest time into it. One of the instructors described MIG welding as a point and shoot process. Thirdly, MIG welding are clean and efficient. Since MIG uses a shielding gas to protect the arc, there is very little loss of alloying elements as the metal transfer across the arc. There is no slag to remove, which is typical for stick welding, and only minor weld spatter is produced. After a brief cleanup, MIG welders will be back on the job in a fraction of time thanks to the minimal cleanup it requires. Furthermore, MIG welding is extremely versatile and can weld a wide variety of metals and alloys, while operating at a variety of ways such as semi and fully automatic. While MIG welding is useful for many home welding projects, it is also used for a large number of industry. MIG is used for metals such as aluminium, copper, stainless steel, mild steel, magnesium, nickel and many more other alloys, as well as iron and most of its alloy. And of course, every products do have their disadvantages, but it's mine. The first disadvantage, it is cost itself. Welders will notice right away that MIG welding equipment is more complex and costly, while also sacrificing portability. In addition, shielding gas, electrodes, and replacement tips and nozzles for MIG welding can add up. Next, MIG welding has limited precision. The fluidity of the welding puddle and the high heat input of a MIG welder rules out is vertical or overhead welding, while some welders would never even think of welding in one of these positions. Take this fact into consideration when deciding whether or not to purchase a MIG welder. to make sure it can accomplish all job planned for it. Moreover, this welding isn't suitable for outdoor welding. Besides not being portable, MIG welders are also unsuitable for working outside since they are using shielding gas to protect the purity of weld. Wind will play the havoc with the shielding gas and impact the quality of weld. A MIG welder also can't be hauled out into a field to repair a tractor, but works great in a garage for automotive works. MIG welding also has fast cooling rates. Indeed, it's bad because the welded metal will cool at rates that are higher since they aren't covered by slag when the weld is completed.
Hi, my name is Kabileesh, son of Govindarajoo. The matrix number is 09 DKM 20F2002. Today, I'm going to talk about types of joint in car welding. First of all, what is joint? Joint is a welding joint is a point of edge where two or more pieces of metal or plastic are joined together. They are formed by welding two pieces or more pieces according to a particular geometry. There are many types of joints. For example, butt joint, T-joint, corner joint, head joint, and lap joint. Now I'm going to talk about welding joints in a car. There are four kinds of welding joints that are commonly used in a car welding work. Each joint piece can serve a number of different purposes based on their shape and where on a car they are to be placed. The three types of weld joints are listed as follows. First one is butt joint. A butt joint is a type of joint between two edges of different metal pieces that are lying in the same direction. The joint of this type may be either square or groove. Second one is corner and T-joint. The corner joint is a joint between two edges of metal piece that meet at perpendicular 90-degree angle. A T-joint is a joint between two pieces of metal where one piece edge is perpendicular to the surface of the other. The corner joint forms an L shape and the T-joint has the shape of the letter T. Both joints are commonly used in many types of metal structures, especially in a car welding. The final one is lap joint. A lap joint is a joint between two pieces that are overlapping one another. The strongest types of joints available. However, the maximum point efficient, the overlap should be the metal of minimum of 1/3 the thickness of the thinnest member of joint. Lap joint is used with torch brazing and spot welding application. Thank you so much.
Good morning to my teachers and my fellow friends. So my name is VINALESAN RAMAMURTHI. DKM1A is going to talk about the safety element during welding a car. Welding is a dangerous job that can give a heavy damage to our life. That's why welding is a high paid salary job. Tools are main important in welding. Tools are main important in welding. The welder should use the correct equipment to make sure the product is good and to ensure their safety. First of all, welding with side shield. Welding helmet with side shield. Welding helmet will protect the welders from UV radiation from the oxygen as a thin flame. Rather than welding helmets, welders can use welding goggles to protect their eyes from the UV radiation too. Welders also must use welding apron. It can prevent them from a hot slag. Welding is a very hot process of work. A lot of heat is needed and the place can easily catch on fire. So the welders should use gloves for fireproof clothing and boots to ensure their skin is prevented from the chemical burns and able to rescue them easily if any accidents occurs. Welders is guided to use respirators when welding process because fumes and oxide is produced and it can damage their health. Ear protection is a compulsory because a lot of noise is produced in the workplace. It's better to use a fire-resistant ear protection. It can protect from the risk of spark or splatter entering to the ear of the welders. So second is the procedure to do welding. Welding is not an easy process. It has its own procedure to do it. Usually welders are well trained and use the procedure. There are two types of welding used for car. Welding most commonly is used is MIG, which is metal inert gas, and oxyacetylene welding. The procedure of MIG is first an arc is struck between the end of a wire electrode and the workpiece, melting both of them to form a weld pool. The wire serves as both heat source and filler metal for the welding joint. The wire is fed through a copper contact tube which conducts welding current into the wire. The weld pool is protected from the surrounding atmosphere by shielding gas and fed through a nozzle surrounding the wire. Shielding gas selection depends on material being welded and the application. The wire is fed from the rear by a motor drive and the welder moves the welding torch along the joint line. Well, oxyacetylene is moving. First, we must separately purge both of oxygen and fuel gas lines. Then we should open the fuel gas valve in half turn. Then we should initiate a flame with the striker. We should increase the fuel gas flow until the flames leaves and no smoke is prevented. Then decrease the flame to tip of the striker. So we should open the oxygen valve now and adjust the neutral flame, and we should depress the oxygen level to make sure necessary adjustment and welding and start welding. Well, that's all for me. Thank you.